All right, guys, so this is kind of how I want to do the notes. In this assignment, you'll see this video and a PDF of the notes that you'll be seeing behind me and obviously on your screen. Now, the homework assignment is always going to be in the header, so you know what to expect for homework, whether it's an attached worksheet or if it, in this case, is bookwork. Now, what I recommend you doing is taking out your textbook or your PDF and looking at the questions ahead of time. That way you know what you're looking for. And so as I'm going through with the PowerPoint, not the PowerPoint, the presentation, you can go ahead and write down the answers as you find them, snap a picture, and then submit it. Now, if you have any questions, obviously feel free to email me or hop into the Zoom and just ask me. Now, I did reach out and contact people that have been struggling with submitting their work. If you are one of those people, this is your warning shot. If I don't hear from you in the next day or so and I don't start seeing some work submitted, I will reach out to your parents and then to Mr. Barch if need be. So please reach out to me and let's figure out what's going on. So with the notes today, it's Chapter 7, Section 1, Sampling Distributions. So the first thing I want to talk about are two words. The first one is a statistic. So a statistic is a numerical descriptive measure of a sample. So whenever you say, what are the statistics of something, actually only referring to the sample, not the entire population. Three symbols that correspond with a statistic would be X bar, which is the mean, S, which is the sample standard deviation, and this is a new one, it's called P hat. P hat means that we have a sample proportion, and that's always given with a percentage. The second word we'll go over is a parameter. A parameter does the same thing. It's a numerical descriptive measure, but it's for a population. So symbols for a parameter would be mu, which is the mean, sigma, which is the sample standard deviation, and then P, which is the population proportion, which is also going to be given in a percentage. Now, if I'm ever moving too fast, obviously I can't read my audience, so what I would expect you to do is just simply pause the video and then restart it as needed. There are three types of inferences. The first inference is called estimation. Now, what's kind of cool about these three inferences is it's going to give the framework of our next three chapters. So the next chapter we're going to be getting into is going to be talking about estimate. We are going to estimate the value of a parameter. Now, this means that we are able to collect some information, that would be our sample, and then we are going to predict to what the value of the average would be every single time. Now, we obviously can't be 100% certain, so what we're going to do is I'm going to say, given that my average is this, I think that the known average will probably be between, and then a number a little bit before and a little bit after. That's what we're going to call our margin of error. Then that can vary depending on how confident we want to be with our range. The next inference is testing. That's when we formulate a decision about the value of the parameter. Is it something that we can consider to be accurate? Can we say with a certain level of confidence that something might be happening? Do we think that the first value is greater than the second? Do we think that there is no statistical difference? Do we think that they're about the same? So those are some of the conclusions we can formulate with the testing. And then the third and final inference is when we do a regression. Now, that's when we make predictions or a forecast about a statistical variable. So given that we know a sample, what do we think is going to happen in the future? So this really breaks up our last three chapters, and this is where we'll end the class, is when we get through regression. Now, the big vocab word of this section is a sampling distribution. Now, a sampling distribution is actually what you guys are doing at home with your activity that you're measuring. It's a probability distribution of a sample statistic based on all possible simple random samples of the same size from the same population. So what I've asked you guys to do is to do something. Some of you can do the activity once and measure that, whether it's how many you did in a certain amount of time or how long it took you to do something. So your sample size would be 1, and you're collecting 100 samples. The population that you're drawing from is every single time you would ever do your activity. That's what we're going to be estimating. So if you're walking your dog or drawing a picture, obviously we're not going to know how long it's going to take every single time you draw your picture, but based off of a sample of 100 data points, we can make predictions. So an example that some people have done is shooting a ball 5 times. Well, your sample size for that experiment will be 5, and then you would do it 100 times. So they're all the same sample size of 5 shots. You're doing it 100 times, and it's drawing from the population of whenever you pick up a ball and you were to shoot it, what's the probability or how many times should you expect to score out of 5 shots? The theory behind the sampling distribution is that the more samples you can obtain, the closer we'll get to a normal approximation. An approximation to the normal distribution. I'm looking at the words out of the corner of my eye and got them mixed up. So if we were just to do something a few times, it's a binomial experiment. Either you make the shot or you don't. There's a probability of that happening. Now, as we have more and more of those samples, what will happen is that the outcome that should occur most frequently will be the peak of your curve, and you'll have so many options because it'd be from 0 to 100. So you'd have 101 little bars if this was binomial. And then as you have more and more and more, they start to squish together and it starts to form a nice normal curve. So that's the idea behind the activity. That's why you had to do so many of these, is because we needed enough samples so that we can, in our good statistical consciousness, make an approximation using the normal distribution. So go ahead, try the homework. I'll be in Zoom sitting there waiting. If you need anything at all, feel free to come in. If I haven't talked to you yet about what you're going to be measuring and you have some questions, come on in and we can start to discuss it.